You probably think insects have always been small and mostly harmless, the kind of thing you swat away or step over without a second thought, and for most of human history, that assumption has been perfectly reasonable. But rewind the clock far enough, long before dinosaurs, long before most of the animals you'd recognize even existed, and that assumption falls apart completely, because there was a stretch of Earth's history where insects and their arthropod relatives weren't just bigger. Some of them were large enough to be genuinely dangerous to anything sharing their swamp. This was the Carboniferous period, roughly 359 to 299 million years ago. And the reason it produced monsters wasn't some fluke of evolution deciding to swing for the fences. It came down to something much simpler and much stranger: the air itself. Atmospheric oxygen levels during this period are estimated to have reached somewhere around 30 to 35%, compared to the roughly 21% we breathe today, and for most animals, that difference wouldn't matter much. But insects and arthropods don't breathe the way we do. They don't have lungs pulling air through a circulatory system. Instead, they rely on a network of tiny tubes called tracheae that deliver oxygen directly to their tissues through passive diffusion, which works fine at small sizes but becomes a serious limiting factor as body size increases, since oxygen simply can't diffuse fast or far enough to keep a large body properly fueled. So for millions of years, body size in arthropods was basically capped by how much oxygen was available in the atmosphere. Raise that oxygen level significantly, and suddenly that cap gets pushed way higher, and evolution, given the opportunity, tends to take it. Which brings us to Meganura, one of the most iconic products of this high-oxygen world. Meganura was a dragonfly relative, technically part of an ancient order called griffinflies rather than true dragonflies, but close enough in body plan that the comparison holds up visually. And the numbers here are genuinely absurd for anything with the word insect attached to it. Wingspans for the largest known Meganura specimens reached up to 70 centimeters, or about 28 inches, which is wider than some hawks and comfortably larger than most eagles you'd see today. Just to put that into perspective, that's a flying insect with a wingspan longer than a house cat is tall, buzzing through carboniferous swamps with the kind of aerial dominance that no insect since has ever come close to matching. And Meganura wasn't just big for the sake of being big. It was an active aerial predator, using its size and maneuverability to hunt other insects and possibly even small amphibians, which at the time were among the largest land animals around anyway. Its flight muscles and wing structure suggest it was a capable, agile flyer rather than some lumbering, oversized bug barely staying airborne, meaning this thing could actually chase down prey through dense vegetation with genuine speed and control. So if you'd been standing in a carboniferous swamp and heard something buzzing toward you, there's a real chance your instinct to duck would have been the correct one, even though, to be clear, there's no solid evidence it had any particular interest in attacking anything human-sized. Small comfort, given everything else sharing that swamp with it. Because Meganura, as impressive as it was, wasn't even the most unsettling thing crawling around during this period. That title probably belongs to Arthropleura, a giant millipede relative that makes modern millipedes look like a rounding error by comparison. Length estimates for the largest Arthropleura specimens reach up to 2.6 meters, or roughly 8.5 feet, based on fossilized trackways and partial body segments discovered primarily in what's now the UK and parts of North America. So picture a millipede longer than most cars, a wide, segmented, armored, and moving across the swamp floor with the kind of unhurried confidence that comes from being, at the time, essentially the largest land-dwelling arthropod to have ever existed. For a long time, the assumption was that Arthropleura, like modern millipedes, was primarily a detritivore, slowly working its way through decaying plant matter on the swamp floor rather than actively hunting anything. And the fossil evidence broadly supports this, with most researchers agreeing it likely fed on decaying vegetation, spores, and possibly some small invertebrates it came across along the way, rather than functioning as an active predator the way Meganura did, which honestly doesn't make it any less unsettling, because harmless plant eater and still 2.6 meters long and covered in armor plating aren't mutually exclusive descriptions, and simply being in the same swamp as something that size, regardless of its diet, would have been an experience. So here, you had an ecosystem stacked with giants, eagle-sized dragonflies patrolling the air, car-length millipedes patrolling the ground, and this wasn't some brief evolutionary anomaly either. These body plans persisted and thrived for tens of millions of years, which in evolutionary terms is an extraordinarily long, stable run. The high-oxygen carboniferous atmosphere wasn't a temporary spike. It was the baseline for most of the period, which meant gigantism in arthropods wasn't an accident. It was simply what happened when you removed the usual size ceiling and gave evolution enough time to explore what was suddenly possible. But atmospheres don't stay the same forever, and eventually oxygen levels began a long, gradual decline, heading into the Permian period that followed, driven by shifts in plant life, climate, and the broader carbon cycle. As oxygen concentrations dropped back down toward levels closer to what we see today, that same tracheal diffusion limitation that had been loosened for tens of millions of years snapped back into effect, and the size ceiling for arthropods came back down with it. Giant dragonfly relatives and car-length millipedes simply weren't viable anymore once the atmospheric conditions that allowed them stopped existing, and over time, arthropod body sizes across the board trended back downward towards something closer to what we're familiar with today. And that's really the core of this whole story, that insect gigantism was never some evolutionary experiment insects were working toward. It was a direct, almost mechanical response to a specific set of atmospheric conditions that happened to exist for a long enough stretch of time to let evolution run with it. Change the air, and you change the ceiling, which honestly should be a little reassuring the next time you're annoyed by a spider or a beetle in your house, because the only reason it's small enough to squash with a shoe rather than large enough to be a genuine problem is quite literally the air you're both breathing. Thanks for watching, and until next time.